webinar series. This week we will be discussing energy conservation. My name is Emily Brooks, and I will be assisting Kirk Williams as he presents this week's topic for you. Quick housekeeping, if y'all have any questions, please put them in the chat box and we will try to answer them throughout. If we do not get to your question, we will try to answer them at the very end if time permits. Now a quick bio on our presenter today. Kirk Williams is the chief of the mechanical section for the Fort Worth District. He has been with the Fort Worth District for 12 years. Kirk has extensive experience in sustainable design and development, commissioning, lead, energy modeling, and LCCAs. He has served his career as a technical authority, subject matter expert, and designer on a wide variety of buildings for the DoD as well as other federal agencies. He has designed several buildings that have achieved LEED certifications. Kirk holds a bachelor's degree in mechanical engineering from Texas Tech University. He is a registered professional engineer in Texas and certified energy manager, and is a certified building commissioning professional. He was born and raised and currently resides near Fort Worth, Texas. With that, I hand it over to Kirk to start the presentation.
Okay, great. Thanks, Emily. So glad y'all could join us for energy conservation. This will be a good one. Lots of information. Probably crammed a little too much into this webinar, but we'll see what we can get through. There's a lot to talk on this. Y'all, like she said, y'all are encouraged to put things in the chat. We'll try to touch on as many as we can, but if we have to, we may push answering some of the questions to the end. So, appreciate that. We'll jump into it here. Okay. So our objective today is to organize the strategies to comply with the Army's energy conservation requirement. We won't dwell on this real long, but we're gonna talk energy conservation and the requirements and some of the policy that go along with it. So with all the webinars, we've included a resources tab here. Pretty similar one to what we had before. Went ahead and added the ASA SDD policy link here for those that attended previously. I don't know if we had that on some of ours. So went ahead and added the SDD policy here. A lot of the other criteria are pretty familiar. Obviously, the UFC 1200-02, that's what a lot of the webinars are based around. We have our MS Teams site where we're uploading the presentations, the chat where we've answered some questions, and then just kind of general kind of forum discussion. We have the International Green Construction Code. Excuse me. I will probably accidentally refer to this as 189 throughout the presentation, so forgive me for that. But it used to be ASHRAE 189. It's now the IGCC. And then Lead Online. So some of the resources, a lot of people, if you've been attending the webinars, these will look pretty familiar to you. Okay, so we're going to jump into the UFC, primarily Chapter 2-3, where we're going optimize energy performance. So some of the topics that we're going to discuss today are energy efficiency, energy efficient products, standby power devices, on-site renewable energy, metering, and then also a real brief conversation on compliance documentation. There's actually going to be another presentation on documentation, so we won't go in a real deep dive on this, but there is some specific energy compliance documentation that I thought it would be helpful to have as part of the energy presentation. So I didn't want to fail to provide on my last presentation. If y'all attended the LCCA one, I put Bigfoot in there, so I felt like I owed y'all some kind of random picture slide. So this is my my attempt at humor. So the visual aid for the visual people like myself is Garfield for this presentation. So you can virtually raise your hand if you had lasagna for lunch or any of the other kind of inner Garfield isms that you have. So some interesting kind of just facts about the government and our energy usage. Offices, hospitals, supermarkets, and other kind of facilities like that account for nearly half of all the energy consumption in the United States. And that cost for those utilities is around $300 billion per year. And it's more than any other sector of the economy. These are coming from the Energy Star and FIMP. So some of the data coming from there. Out of all the energy, often up to 30% or more is wasted through inefficiencies. Improving energy efficiency is the single largest way to eliminate waste. And then with more than 350,000 energy utilizing buildings and 600,000 vehicles, the federal government is the nation's largest energy consumer. So why are we talking energy conservation with this? Obviously, just kind of based on some of the stats, you can see energy usage is by the federal government is a pretty big impact on our nation. And so to be good stewards of our resources, conservation is a really straightforward method to reduce, the usage, the requirement for that utility, as well as the cost and the burden on the taxpayer. Okay, so we'll jump in. Similar to my other slide presentations, I like to kind of give a policy tree or kind of explain where we are and kind of the big picture. I like to give a roadmap of where we're going. So this will probably look a little familiar to a lot of y'all. So we start with the federal laws, executive orders, and then you kind of work your way down through the policy all the way to USACE and ECBs. And kind of just wanted to point out, in the previous presentation, went ahead and listed the SDD policy and the USACE kind of parallel to each other. I think correct pecking order would be as shown here. Sometimes we kind of just think of them as equal, but there is a little bit of a hierarchy there with that. And then just wanted to highlight the main kind of document that we're going to be discussing today is going to primarily be directed out of the UFC, talking compliance with that. We won't go real deep into the Army SDD policy, the ASA SDD policy. I'll try to point out a few of the things as that relates with some of those. And then I guess kind of specifically, one of the things that we're not going to go down is the SDD policy actually has a requirement for energy use intensity reporting. And so just kind of not going to go down that rabbit hole with this presentation. As I was putting it together, I was starting to go there and then realized I was going to probably have more content than I'd have time to actually cover. So just kind of wanted to put that kind of keynote out there of there is additional requirements in the SDD policy. Highly encourage y'all to review that while you're reviewing the UFCs as well as the current ECBs to help you stay current on your policy and criteria. Okay, so now we'll actually jump into the energy efficiency. So the first part that we're going to touch on is going to be out of section 2-3.1.1, and we're going to talk commercial for a little while. And then you'll see that we'll kind of touch on a few of the other kind of genres with it. And so kind of like I did with the other ones is I wanted to kind of pull out some of the highlights for people. I'll say, these are my highlights, and the best way for y'all to know what is in the criteria is for you to read the policy yourself. Definitely encourage that. This is, a supplement to that, but not a replacement. So please don't skip reading the policy yourself or criteria, and just hope that everything has this. And so, okay, so we'll jump into the first one. And so wanted to start out by pointing out commercial and multifamily high-rise. So when we look at the criteria, you'll see that it's actually broken out commercial separate from low-rise residential. And what you'll see is that ASHRAE 90.1 doesn't cover low-rise residential, and low-rise residential, by their definitions, are going to be 3 stories or less. So that's an important thing. And then jumping into the next is we're going to base our energy efficiency design decisions on LCCAs. that shouldn't be too shocking after we've already had the LCCA conversation. We talked quite a bit on the different LCCAs and the methods. So to support our energy choices, we're gonna provide LCCA documentation to show that we did thorough analysis and that we have some standing for the decisions that we've made. And you can refer to the other parts of the UFC for the LCCA requirements as well as the previous LCCA. I just want to point out that we are, with our LCCA, we're providing 3 alternatives that are comparing against the ASHRAE 29 baseline. And so then we'll jump into the criteria. Actually says that we're going to meet ASHRAE 90.1. And so there's a lot of information buried into that one statement of compliance with 90.1 is it sounds like a simple method, but there's actually a lot of winding paths that live within that. And so I'll kind of start by summarizing that, our designers or AEs should be defining the path that they're going to be using to comply with the different parts of ASHRAE 90.1. And so you'll see on the graph here or on the picture that I went ahead and put out of 90.1, they have some schematics at each of the sections that talk about the method for achieving compliance. And you can see that there's multiple different kind of avenues that you can go down. Most of ours are not going to typically qualify for the simplified approach. I don't know if I've had any projects that actually kind of fall on that threshold. So a lot of mine have had to go through the mandatory provisions and then choosing prescriptive or an ECB method. And so just kind of a note for those of y'all that perform review, a great resource is actually pulling out criteria and checking the mandatory provisions as well as, prescriptive path for compliance, is that's a good way to perform a review is to go through and make sure that they're not omitting something from a mandatory provision. And so we'll touch a little bit more on Section 11 ECB method here as we keep moving on, but just kind of wanted to talk through the requirement is that we're going to actually meet 90.1 compliance and kind of just give y'all an overview of a roadmap for one of the sections. So there's also building envelope, there's electrical, and there's other sections from 90.1 that will have requirements as well. Okay, so this is probably the one that people are most familiar with out of the UFC, where we state that we're going to design to achieve at least 30% energy consumption reduction. And then the statement that a lot of people are familiar with is if a 30% reduction is not life cycle cost effective, that we're going to modify the design to achieve an energy consumption level at the highest level that's the life cycle cost effective. And so this is where we kind of have, sometimes we're dealing with buildings that it's really kind of difficult to get 30% savings. They're a really simple building. They have a process that, is kind of difficult. It's kind of a high bar for some facility types. And so we have kind of the path around that says, if you can't hit this metric, then you're going to do your LCCAs, which we're already doing, and you're going to choose your method that gives you the most energy savings to try to comply with that. And so I just want to point out kind of a reminder from the ER on LCCAs and energy modeling that it actually states where you have similar performance, but by alternatives that you select the most economical, as well as a reminder from the ECB on LCCAs that says when you're selecting alternatives for analysis, give a preference to features and systems with lower complexity and maintenance burden. So sometimes this can be a little bit of a gray area to try to balance all three of these. And I'm sure a lot of people that have lived in this realm have had to kind of work in this realm of selecting the most economical. Typically that means the lowest first cost, which usually those are not your highest energy performers. Lowest complexity and maintenance burden, that may not be the cheapest one, but it may be the simpler one, something that, a lot of the maintenance personnel or someone may be interested in, and how that compares possibly to the highest energy efficiency. So there is a little bit of balancing act. I do kind of expect as things get kind of revamped with policy and things, that some of these kind of statements might line up and kind of mesh and smooth out. But I just kind of want to point some of those out for y'all. And then I just kind of wanted to bring up a general note that as we kind of talk lead here, that usually kind of comes up because a lot of people look at the energy consumption savings and they think, oh, this will relate to if I model my building for LEED and how many points I will get. So I just kind of wanted to point out that LEED uses energy cost savings, which will vary based on your utility rate and doesn't directly align with energy consumption reduction that's called out by the UFC. And we'll touch on this a little bit more. You'll see that I'm going to bring this up a couple times. It's something that is a common misnomer, kind of almost like using the wrong units. So as we're continuing in the UFC here, a lot of people are familiar with this one. It says that we're gonna use the performance rating method for determining our compliant, or for determining our percent energy reduction over the ASHRAE 90.1 baseline. And so our UFC actually gives us an equation to use. So that's always fun. Just wanted to point that out for those of y'all that might be new to the federal government, that there is this equation here that when you're doing your UFC compliance reporting, you would use this, which is more or less taking your receptacles and process loads out of it to kind of reflect a different value. This is another area where the government is going to differ from LEED. Of LEED is going to include your receptacle loads in the analysis. So there will be differences between the reporting of those two. So once again, I said you'll hear that about every slide here. There can be a difference between your UFC reporting and your LEED reporting. Okay, so I think it's helpful when we get some real world examples. So I went into some old projects and I pulled some data out of Trace. Unfortunately, that's what you get when you give an engineer presentation, is you get data. So sorry for those that like pretty pictures. So on this one, just kind of wanted to point out. So the top one is a report out of Trace. It's your energy cost budget / PRM summary. A lot of people are familiar with this, and I just highlighted the total consumption, noting that the units of this are 10 to the 6 on BTUs, I believe. And so they're actually a pretty large value. And then the one on the bottom is actually the same energy modeling software output summary for LEED. And that's where it actually points out our proposed economic cost improvement over the baseline. So that's what would relate to our number of credits that we would achieve. So I went ahead and pulled, this is actually that ECB PRM report, the whole one. And I just went ahead and circled a couple of things. Here you would see where we have the receptacles. If you remember back to that PRM equation, we talked about receptacles getting pulled out in relation to the total building consumption. So to not get into the math, it wasn't real jazzy math. If you backed out the numbers, you would see that this building was, by the UFC method, 45% energy consumption reduction. And then with the LEED energy cost savings, we saw that we were 25%. So this is where I'm really trying to drive home that if you're at a planning charrette or some other kind of function or venue, selecting that you're going to get 30% energy savings on lead is going to be a very different output than what you might be getting from your UFC. So just because the UFC says you're going to be doing 30% reduction, or the maximum life cycle cost effective, doesn't necessarily mean you're getting all of those points with lead. So talk to your energy modeler, talk to your mechanical, talk to your PDT. Hopefully people are informed about that, but I've come into multiple projects in-house and AE where we kind of started with that assumption and then kind of had to be the bearer of bad news of, no, we're not going to get you 12 to 15 points on this or credits on this. We are going to be getting you more like 6 or, a lower value. And so that can be a big deal when you're planning your third-party certification compliance. So just kind of wanted to point that out there. Hopefully everyone's gotten that. Kind of an interesting thing with this is a project from 2016, and so you might be looking at this and saying, why is there such a great delta between, this UFC energy consumption reduction and this lead cost savings? We actually had a very low utility rate on this project, so we were using electricity that was around 7 cents a kW and around 70 cents for a therm. And those were 2016 values. And so I just for kind of argument's sake, I went in and pulled the EIA because these were EIA values. And so I went ahead and pulled the 2020 ones, and the electric rate had actually gone down by a fraction. So I was going to say, yeah, see, here's how much more, we would have if the rate was modern, but the rate actually stayed low per the EIA, state average reporting. So that was kind of interesting. But that's just kind of a side note on that. But like I said, this is all just kind of for presentation, just to kind of convey that, UFC reporting values are going to be different than your lead reporting values. And it's really because you're using different units. Okay, so we're gonna keep diving into the commercial. So we're going to determine our consumption levels for the baseline and propose using the performance rating method. So there's a little bit of a difference between this. Sometimes people can get confused with the performance rating method and the energy cost budget method. Those of y'all that live in energy modeling or 90.1 compliance have probably come across this. Energy cost budget is a modeling method. It's actually section 11, and that's a method that you would use for showing compliance with 90.1. Appendix G, or the PRM method, is actually if you're going to show that you're achieving savings, energy savings above and beyond 90.1. So they are actually different. There's some differences, as you can kind of see on the statements that I put on here. The PRM method builds on top of the ECB method. Those of y'all that have done any kind of energy modeling for lead, they drive home, compliance with Appendix G requirements. Lead reviewers are really good about making sure your baseline is fully compliant with Appendix G. They will give you plenty of comments if you fail to do that. We know firsthand. So just some things to note with that. There's a lot of great web resources. I'm not going to go real deep into it on the ECB method versus the PRM method. There's a bunch of probably graduate student papers on it. So I'll just Google it, and you'll probably find more information than you really care to. I did want to kind of point out that typically, if you're doing lead, which we're tailoring this, webinar series around Army. Lead is Army third-party certification. So if you don't deal with that, kind of bear with me as we go through here. But typically, with a lead project, you're going to end up with 2 energy models to prove compliance. You're going to have your proposed versus an ASHRAE 90.1 2013, which is your UFC compliance. And then you will likely have a proposed versus a 90.1 either 2010 if you're using lead version 4, or a 2016 90.1 if you're using LEED version 4.1. So hopefully people are tracking that. There's some ways to optimize your modeling. A lot of times we do a lot of our work and then we track the difference between the versions on our model and make those changes. But there will be different outputs, and so as you're reporting for your UFC versus your LEED, you do have to be kind of aware that you may not be using the same baseline that you're competing against. So, like I said, a lot of people, this is kind of old news, but just want to give kind of a 10,000 foot elevation of sometimes you may see multiple energy modeling things out there, and it's probably not because your energy model or mechanical was bored and wanted more things to do. So now we'll jump into a real high-level overview of the residential. We kind of talked the UFC mandates for the commercial. So now we'll touch on the residential real quick. So to meet the requirements of the residential, and just kind of a reminder, this is 3 stories or less, and typically involves like a dwelling unit, gets into kind of your classification spaces. You're going to follow the International Energy Conservation Code. So we wouldn't be using 90.1 for this necessarily, because 90.1 said that it doesn't cover low-rise residential. I just kind of put a note in here that sometimes we get into kind of a strange criteria crosswalk issue with large barracks that are 3 stories or less. So sometimes we have, AITs, UEPHs, and things like that aren't actually high rise, but are pretty large residential. And so you get into kind of some strange comparisons when you actually start using the IECC, which is, more geared towards low rise residential. You can kind of think a house, but you're dealing with, a barracks that's hundreds of thousands of square feet, and kind of make getting apples and apples kind of comparisons a little difficult. So some of that might live out there for some of these. Other things that you might come across are actually falling under like the LEED for Homes rating system and getting away from the BD plus C. And so some of that lives out there. Hopefully as people get into those things, they can document that and kind of leave a breadcrumb trail for themselves in the design analysis of where they made their decisions. So we're going to see a pretty similar requirement here to design to achieve a 30% energy cost consumption reduction, but we're going to be using the IECC instead of 90.1 on this. So pretty similar statement, just different criteria. Once again, we have the same caveat with life cycle cost effectiveness, where we're going to do the highest energy efficiency that's life cycle cost effective. If a 30% reduction isn't cost effective, then you're going to just choose the highest level of energy savings that you can. Okay, so that was a real high level on residential. Next, we're going to talk renovations, and this one's kind of an interesting one as well. There's, as a lot of y'all are probably familiar with renovation work, there's kind of an infinite amount of variety with the scopes on renovations. So to start with, the UFC says if you're replacing everything above the foundation, you must. And then it goes into, apply either the commercial or multifamily high-rise residential, apply the low-rise residential, and achieve one of the compliance methods previously discussed. So more or less, it says if you're going to replace everything from the slab up, if you're going to kind of rebuild this thing, you're going to follow the 2 methods that we used for the new construction. It makes a little bit of sense because you're kind of getting into that deep energy retrofit kind of scenario. So that's what you're looking at. And then you're going to get into for all other renovations. So for all other renovations, you're going to choose one of the following options. You're going to reduce your measured building energy use by 30% below a 2003 metric. That for the baseline, you're going to reduce your building energy use by 20% below a 2015 metric. So you have kind of a difference there. Or you're going to reduce your modeled energy by 30% compared to 90.1. So that one looks kind of like what we had in our commercial there. So just kind of a little caveat here is a lot of times, and maybe it's different for where we are, but a lot of times we have a hard time getting as-builts on our renovations. So sometimes, going and asking for meter data to create a baseline may be, kind of asking for the moon. So not to say, you can't go that route, but I'll say a lot of ours, we end up going the modeling method just because getting data, especially meter data, to create the baselines can be a pretty tall ask. So just keep that in mind, but you do have a variety of choices there. So, weighing that against the data that you have available and your project scope. Okay, so that covered most of the energy efficiency that a lot of people are familiar with. The 30% energy savings, the kind of the big key one that people think of when they think of the UFC and some of the energy compliance that goes along with it. Now we'll kind of touch on a few of the other ones. So the first one, and this one might look kind of familiar to y'all that attended the water presentation, is we're going to get energy efficiency products. So we're going to get products that are Energy Star qualified that meet the FEMP designation for energy efficient products. So I actually put links on the slides here for Energy Star and for the product list from the Department of Energy for the FEMP. And then I thought this was kind of cool that kind of broke out the federal government's energy and water use by consumption fuel type from 2020. So if y'all like to nerd out on data and graphs, I have those moments every now and then. The FEMP website has a lot of information on that. They also actually have some pretty cool tools on there. I came across an alternative water source map. If you were there for the water presentation, we talked alternative water. And they actually had a tool where it shows different alternative water source available locations. They have a water harvesting calculator. They have a tool for economic viability for PV, wind, battery. So there's some tools out there. I kind of, am weary to promote too many tools because, at the end of the day, our LCCAs are required by policy, and we have, the requirements that are there. But sometimes those tools are fun to kind of get to look at and just kind of, test the water and see kind of some of the results in your area or some of those kind of things. It's just interesting to see kind of some of the tools and different variety. They also have annual energy data and sustainable performance data and graphs. So that's kind of like one of the things that I have here. I probably just touched the tip of the iceberg on some of that, but there's some interesting things out there if you want to do that, as well as actually looking through the list of energy efficient products. Maybe as you're making purchases for your home or something to that level. Okay, so next one we're going to talk. So the criteria says you're going to provide a commercially available off-the-shelf product that uses no more than 1 watt in their standby mode, provided it's life cycle cost-effective, practicable, and performance is not compromised. So easy example for kind of real world is here on the screen of an occupation with machine. machines had these on there. So good job being sustainable. I've enjoyed this because I love the label miser. That's what. But yes, this would be an example of, okay. And my mic, is it getting any better? Hey, can y'all hear me?
Yes, sir.
Okay, good. Sorry, I was using my work phone and my reception went to 0. Sorry about that. So let me get the presentation back up and we will jump back into it. Sorry for the technical delays. Okay, sorry about that. So hopefully y'all are with me and we can pick back up here. We'll take the technological issues in stride. Um, Let me know if we have any other issues. Hopefully the Wi-Fi will hold out here and we won't have any other problems. Okay, so I'll kind of back up a little bit on the standby power devices. So these are trying to limit our energy use when the products or equipment are not in use. So it kind of makes sense if we're not using it, why don't we shutter our energy usage? So provided a picture here of an occupancy sensor with a controller on a vending machine. I don't know how many people heard this, but New Orleans district, when we were there at the mechanical COP, wanted to give them a shout out. Their district office had these on their machines. So good job being energy efficient. And then I love energy conservation where miser is a good thing. So being miser controllers is a good thing. So next we'll jump into on-site renewable. So this is one we're gonna park on for a few minutes. A lot of people probably have come across this. This is kind of like the 30% energy savings. There's a lot of content here. So our UFC says we're gonna provide on-site renewable energy, and we're gonna follow the IGCC, so the former ASHRAE 189, but we're going to do it where life cycle cost effective. So that's where it's going to get kind of interesting. Is we have this criteria that says, if you were doing ASHRAE 189 or IGCC compliance, you would normally provide for on-site renewables. And there's a variety of definitions that go with that. A lot of people think PV, but there are other renewable sources on site, but that go along with that. And then specifically, there you get down into it, and it says for Army projects, if
if it's not life cycle cost effective, that you're going to on-site renewable energy systems for future installation of on-site renewable energy systems. And so that can get kind of fuzzy on how to implement. I'll say I've seen some good examples, where an AE DOR put the renewables in the project like a bid option. They went ahead and put panels on the roof. They went ahead and they planned their structural around it. They carved out a space in mechanical electrical rooms for this equipment to live. That was them planning for the future, was kind of thinking about it like a bid option. I've also seen some AEs that take this and they say, well, anything is possible if you plan it. So we're going to do our design how we see our scope, and we're going to let the future worry about itself. And you kind of, so you get a wide variety of implementation on this, of how you're going to plan for future with on-site renewables. So I'll say that might be a conversation your district or your engineering branches have independent, or maybe guidance will get clarified as to the documentation levels with the expectations with that. Want to point out that services may choose to life cycle cost effective, centralized, or installation wide renewable energy development. So if they choose not to have it per project or building level, they could actually do it on an installation method. I'll say that probably gets a little bit more complex for USACE. There's probably some planning and just some things that kind of are going to be well outside of the bounds of this presentation, but just kind of noting that is available in there. So the installations do have that flexibility. And then want to point out the exception. We are not going to go out and purchase renewable energy certificates to comply with this. So don't do that. That will probably get you all kinds of recognition you don't want to have. And then just kind of want to talk through some of the highlights from this. So if you go down and you actually look at section 701 for 1.1, it's going to actually say that there's two approaches for compliance. There's a standard renewable approach, and there's an alternate renewable approach. And so the standard renewable approach, your building's going to contain on-site renewable energy systems that provide the minimum values multiplied by the horizontal gross area. So for a single story, you're going to provide 6 kBTU per square foot. So you're going to take this value and you're going to multiply it by your roof area. And then you see that there's a higher value for multi-story. There are some exceptions that go along with this. If you're in an area that has an average annual incident solar radiation less than 1.2 kBTU per square foot, you're going to be exempted. If you're accounting for an existing building, and then permanent infrastructure that's not part of the building project. And so there's some exemptions in there. I'll say, probably looking at that and weighing it with your project. There's some tools out there that'll help you figure out your average incident solar radiation. I'll say NREL or NREL. They have some maps out there. There's some other resources out there, so you can find that data for tracking on your locations. So jumping into the other method now, the alternate renewable. So this one's going to look pretty similar to the standard renewable approach. Your difference here is going to be that you're going to see you're only required to do a marginally lower value of on-site renewable per square foot. And what they do is they say you're gonna provide equipment that meets certain minimum energy efficiency ratings. And there's an appendix, and there's a water heater, and then there's the Energy Star requirements. So a lot of these are probably maybe things that we're already doing on our projects, because a lot of times we're going for LEED, we're going for energy savings for UFC compliance. So we may already be rolling some of these criteria in. So you might end up with a lower on-site renewable. So kind of wanted to point that out to y'all, that there's two different methods, and if you're doing really energy efficiency equipment, you might be well served to look at this alternate approach. This is an example of one of those NREL maps. I'll point out, unfortunately, I pulled a map that had different units than the text in the slide. So check your units, because one of them's kBTU and one of them's kWh. So sorry for doing that to y'all, but that's what I had readily available as I put this together. But just kind of a picture of what you can get as far as some of your data showing you your energy intensity at your different locations. And so if you look at that map, this one's for solar PV. It kind of looks like what a lot of people would expect of the red high intensities, the desert, or some of those kind of areas. I did actually see that question pop up. Yeah, if you're on, Alaska, Hawaii, I'm sure they have some data out there. Like I said, this is just one that I had kind of readily available. There's a lot of, if you get into the NREL and FEMP and some of those sites, there's kind of a data overload. So you can find a lot of good data out there on those sites. Okay, so another one that's pretty familiar with a lot of people is the requirement for solar domestic hot water. So we do have a requirement to provide, excuse me, at least 30% of our annual domestic hot water with solar domestic hot water. And so that comes from ESA 2007. And then there's the important caveat that unless it's not life cycle cost effective. So that's pretty common. I think this one's been around long enough that a lot of people are pretty familiar with it. A lot of people have, kind of their LCCA methods. I'll say a lot of people probably know if solar is feasible with the building type and location where they're working. But I did want to kind of point out, and this is one of the areas that I kind of flagged from the SDD policy. Of the SDD policy does have some statements in here that you don't only look at 30%, that you do look at values higher than 30% to try to figure out if there's a break-even point. So if it's 65% solar or if it's 95% solar, if you have a break-even point. I will say if you get the distinct privilege of getting audited, they will bring up, if you've only looked at 30%, they will ask you about some other percentages. So just recommend that. I believe our team looks at 60 and 80 to kind of get kind of some kind of other metric points to kind of compare for the analysis. So in our UFC, we talk about this energy conservation. A really good way to figure out if you're conserving energy is to have a meter and be able to read how much energy you're using. So this is not earth-shattering if y'all were part of the if you were part of the water presentation. This criteria is more or less the same as the, we were going to meter our water utilities. Same kind of thing. If we're doing water conservation, we need to know how much we're using. And so there's a lot of data on these slides. I'm not doing great on time, so I'm gonna keep moving on a little bit faster through this part. I will say, with the metering, we should be getting what we call an advanced meter. So it shouldn't be a rotary dial. It should be something that can do some data points. It should, more or less be a digital meter. There is the DoD meter policy. I put the link on the slide here. And then a big important point is cybersecurity. So don't provide a backdoor, don't let your building get hacked through the water meter. That would not be popular. So, you do your cybersecurity, include that in there, and communicate with your installation on the metering and their policies and work to have that implemented. Okay, so like I said, we'll do a real high level touch on the compliance documentation. Primarily, I wanted to point out that there's a requirement for an energy compliance analysis. We're going to thumb all the way back into Chapter 4 of the UFC for this. So this is still out of USC 1202. And we're going to provide an energy compliance analysis that documents all of the energy related requirements of this UFC. And I highlighted a few of the things. We're going to have a summary of our input and output calculations. And we're going to have the calculated energy consumption of our baseline and alternatives. There's more data that goes into this. You're likely going to be using a program that's capable of performing a full, 8,760 hour calculation, so a full year weather data. So these are important things. If you're doing reviews, making sure that your AE or other are using energy modeling software that's compliant, that you're getting your energy compliance analysis. I'll say along the lines of if you get the SDD audit visit, they will be looking for this. And so this is kind of a good kind of reminder of here's a requirement for something that should live in your design analysis. So an easy review comment of I cannot locate these documents, and it spells out what you should be looking for here. Another thing I want to go ahead and bring up is part of the energy concert analysis is that there's a narrative. You have these LCCA narratives, and they're supposed to be by the lead architect, lead mechanical, and lead electrical. There's a variety of ways that these are done. When we talked LCCAs, I told y'all we've seen some LCCAs that are like college dissertations, hundreds of pages, and we've seen some 3 LCCAs on 1 page kind of mentality. And so there's a wide variety, but here we see the requirement that we should get some kind of narrative that talks through this. These are helpful for documenting the decision making that occurred during the process, and it's a lot easier to do it when the project is fresh than trying to remember 2 or 3 years after the fact when it's been built and someone comes in and asks a question or something like that. Okay, so just to summarize, I'll summarize here, and then we'll see what kind of questions we have time for. I saw a bunch pop up in the chat, but I don't know if we'll be able to get through all of them in the 6 minutes that we have. So just to summarize, we talked through the energy efficiency that was in the UFC. We talked the policy on energy efficient products. We didn't get into examples. We talked the criteria requirements on standby power devices, pointed out that there's an on-site renewable energy requirement and some of the things that go along with that. We would have advanced metering through our UFC compliant project, and that there is going to be some compliance documentation on the tail end of this thing. So with that, we'll jump into the questions here. Sorry, I can't actually see.
I have a list of them ready for you, Kirk, if you want to do that way.
So Eric, I have not gotten into Trace 3D Plus very much at all. I've kind of pawned that one off on my team. So I don't know about the 2015 comparison. We have a pretty steep learning curve to get ourselves caught up on 3D Plus. With our current workload, we're having trouble prying ourselves away from Trace 700. Okay. EUI by facility type is always problematic. There is insufficient data, yes or no? Yeah, that's part of why I didn't go down that rabbit hole of you start trying to kind of paint some of these facilities with a broad stroke, and the Army's great about mixing kind of 5 different uses into one building. You have half an admin, half a warehouse, and you get some of these kind of interesting things that you can kind of sometimes get, it may work out great for an EUI. It may also work out really, really kind of poor, depending on your use in some of those. Kind of just wanted to point out that in the SGD policy, there is that discussion on that in there. And then I'll kind of let people kind of choose their method with some of that. Do we actually use the prescriptive path much, given the overall needs for energy reduction? So yes, our typical goal is to start out prescriptive. It's really nice to be able to work from a checklist. The QC reviewer that I normally am, I like prescriptive path because can look at it and say, yes, you were compliant versus, trying to get into, did we really fully model everything 100% accurately? I'll say most of the time we don't get to go full prescriptive because we have some feature that excludes us, window to wall ratio, some other thing, some kind of requirement, like we're in a no economizer zone, no airside economizer area where we are currently. So, some of those, airside economizer is going to be a prescriptive method with some of these things. So a lot of times we may get kind of booted from prescriptive method right out of the bat. But it is prescriptively, it can be a lot easier if you're working from a checklist, with that method. I'm not real sure about the DoD criteria expected. This somewhere the ASHRAE 90.1 was to be applied to low-rise residential. Oh, okay, that's probably in relation to the low rise for barracks. Yeah, we had some projects and we're still kind of trying to figure them out because the ICC, the International Code Council, kind of residential version for what we're dealing with really does get us into a residential by type, but we're in a 100,000 square foot barracks kind of thing, and we're not high rise, and so it kind of makes for a strange crosswalk between some of the criteria. So those things can happen out there. I'll say, if you're working with a COS, that's usually the first point of contact I'd go. And then, looking at it with, maybe your SMEs and then reaching out to headquarters, if you really can't get clarity on that direction. Okay, well, with that, I'm gonna turn us loose here. I appreciate everyone. Yeah, so the links and everything will be in MS Teams, and then I'll pull down the chat and I'll see what else comes in. But I appreciate everyone making it. Sorry for the technical difficulties, and hopefully y'all have a great afternoon.